over the entire sky tonight. Now, it's so thin that stars of magnitude, I don't know, maybe 3 or 4, or maybe 2, magnitude 2 and greater, or 3 and greater, are visible to the human eye. And our telescope is picking up a little bit deeper magnitude than that. But I don't know if any of these objects are going to work that are like deep sky objects. But I thought we'd go ahead and say hello, and we've got this new list that we're starting tonight called 1001 Celestial Wonders to see before you die. And I thought, well, some of these are actually like double stars and triple stars. So why don't we see if we can pick off a couple of those and just see how it goes. And maybe before too long, we can always hope that somehow the sky will clear off in the meantime. So how about that? It's great to see some of you back. I see several are active in the live stream already. I'm going to try to get the live stream up on my iPad here on the side so I can just check this audio. Let's see if that's coming through. Yeah, so there's the audio. Larry, good evening to you. Of course, Tiffany, glad to have you here as well. And Vito, thanks for stopping by from Pier-Tech, the people who made our observatory and that adjustable height pier that you see inside of there as well. Roll-off roof Tele-Station 2 observatory. So Vito, always glad to have you stop by. Thanks to that Dean, you're here, I think, and Pete, from all the way over the Isle of, let's see, Wight, the Isle of Wight off the coast of England. The last time I checked you were there, that was about 3:05 a.m. your time in London. I don't know if you've stayed on board. If you are watching and would like to say hello, kind of tell us where you're watching from. That would be great to be able to see you there. Okay, so what we're doing right now, let's go back. Oh, that's actually not a bad focus at all. So that means that there were enough stars visible that at least Nina could do a nice autofocus. Look at that nice parabola, hyperbola, whatever that's called. Let's go up and disconnect this equipment now, and we'll switch back over to SharpCap. We use Nina to focus. If you've been on the channel before, you know that. We use Nina to focus just because the autofocus is so fast and so reliable. So let's switch back now to SharpCap. Okay, that's actually much better than what I'd imagined. So it looks like those high, thin clouds have thinned out a little more. Let's go over to our SkyCam. Take a look there. Boy, it still looks like there are some high, thin clouds in the sky. But we'll get by because, look, we're seeing at least seeing a screen here. Now, our first object that we're looking at is Delta Cephei. Delta Cephei. It's evidently a triple star system. So I'm over here in Astro Planner. And that's interesting that our mount is not showing up there. I don't know what exactly that means. Maybe it's just go ahead and put our mount back just to make sure everything's still functioning. I don't know why it switched positions, but it looks like it's still working. Let's sync with Stellarium and take a quick look at Stellarium to see where we are in the sky. Okay, so we'll back off, not quite that much. So we're looking north-northeast here. And if you can see, we're up here about 59 degrees up in the sky, so pretty high up. I was trying to get away from the horizon. If you're familiar with the Big Dipper here, Ursa Major, and the Little Dipper here, so we're dumping the milk out of the Little Dipper down into the horizon. Now look at this little house-shaped, it's like an inverted house, called Cepheus. And to the right tonight of Cepheus is this Delta star system. And there would be the 3 stars of Delta Cephei. Let's look this up in 1001 Wonders to See Before We Die. It looks like it's object number 706. So we're going to go to object 706, and it says it's a small cluster. No. No. It's a wide binary you'll split. And it tells you how to find it. The primary is yellow and the secondary is blue. It's famous because it's the prototype of a class of variable stars called Cepheid variables. So this was the first Cepheid variable, and you're looking at it in our planetarium software. Such stars expand and contract at exact intervals. So let's go over now and look at it again in SharpCap. So there is this Cepheid variable. We're at 200% there, so we definitely are splitting. But which is the third star? That's the question. Let's go back to Stellarium. Look at the way it shows. There's Delta, but it doesn't identify which ones are the 3 stars in the system, does it? That's not really very handy, is it? Maybe because Cepheid variables pulsate at such regular intervals, what astronomers define as the period-luminosity relationship, researchers can use them as standard candles to star clusters or galaxies the stars are in. Using Cepheid variables, American astronomer Edwin Hubble determined that the Andromeda Galaxy was not part of the Milky Way, but rather an entirely separate star system. Oh, it's evidently just a double star. Over in the list it said triple, but here it just shows it as a double in the book. So let's go back, and sure enough, we're seeing now that's at 100%. So we're seeing the double star, Delta Cephei. Mike, Jerry, good to have you aboard. I just want to go real quick to look this up. Delta Cephei, and oh, it's a quadruple star system. That's all the bigger that gets, which is odd, isn't it? That we can't zoom in more on that. Quadruple star system. Wonder if we can find a better picture of this. Still doesn't zoom it in. I'm curious to get a sketch of the four stars. If we can, real quick, just to see if we can see the 3 or the 4 stars. Nice ads that are coming in, but there's no chart in our 1001 Celestial Wonders. Boy, this picture's coming in so slowly. I'm about ready to give up on it. I think the ads are too much for us. So much for the Encyclopedia Britannica. Well, I kind of would like to see a better chart of that. You know what I'm tempted to do? I'm tempted to open up this Sky Tools if I could figure out how to find it there soon enough, because at least the atlas in there would show us the 4 stars. I just don't know how long it'll take me to. Maybe that's a wild goose chase. Boy, if our chart were better here, it would tell us which one of these is a part of this triple star system. But alas, it doesn't. Well, anyway, why don't we look that up later. For right now, let's go with the double star. The double star system here. Boy, while we're here, it would be nice to know that. Let me see if I can look this up in Sky Tools. It's been a while since I did this, but let's just see if we can find this real quick. Sky Tools will tell us, I think, so Delta Cephei. One of you guys that is experienced might be able to help me. So let's see. What will we need to do here? Let's just add add an object, designation search, and I think we can search for it with SAO 34508. No, didn't find it. Ricky, good to have you aboard. Hello, Pier-Tech. So sorry about the rain there. HD 213306. Let's try that. HD 213306. How about Delta Cephei? There it is. Now let's say add the list. Now, the question is, where did it go? This is a crazy way to just open up an atlas that's fit enough, isn't it? Why are we not seeing it there? What a wild, wild goose chase. And unfortunately, there's no like Control F in Star Tools that lets you go find it. You know, Hipparchus 1109, that's what we needed to know. It's got it listed under Hipparchus 110991. How confusing. Hipparchus 110991. So there it is. Now we say open interactive atlas, I think. Here we go. Yeah, now see, it's got a little bit better atlas for us, doesn't it? So this is A, and that's B, and that's C. So that's why it's called a triple. So we should be able to find in our shape see how there are 3 stars out of the side? Let's go back and look. So here are the 3 stars out of the side, and there's that. So it looks like B is, unless those are the 3 stars out the side. There we go. Look, there's that line. Right there, there's that line. So now B is right here. So it's that bright spot. Right there on the edge. So because the Cepheid, you know, the main star, the alpha star, because it's actually labeled delta, so it must be mislabeled, but because it's so bright, I see it's the 4th brightest star in the constellation Cepheus. So one thing we might do is dial this down a little bit. Let's make this 2 seconds. And see if we can get it so dialed down that it stops being so bright. All we can see is just a little edge there, and it's partly because maybe of our seeing. See how the atmosphere is all tingly tonight? So So we're not going to be able to resolve, tonight anyway, we're not going to be able to resolve unless, look, right there it is. We were looking too close. Right there is the second star in the triple system. Right there, you got a good glimpse of it right there. So that's the third star in the system. That was a lot of work to get to that, wasn't it? Okay, so let's do an observation on this. Back to we had to work to find the third star in the system. It wasn't immediately obvious to us. Had to call up Sky Tools Atlas to know where to look. Then we saw it faintly lost in the primary star's halo. Mother of all Cephei variables. Okay. That was our first observation now of our 1001 objects to see before we die. So now you've seen it. Star splitting takes focal length, Mike says. The RASA has many strengths, but lots of focal length. That's not one of them. Right, Mike. But we did finally see it, even though it wasn't very bright. Let's catch another one here. Let's go to trying to find objects, first of all, that are, it looks like our sky has improved a lot. Look at all those little points of light. So now let's go back to the beginning and see if we can't start now where I wanted to start at the beginning of the night, and it would not see a thing. Looks like Beta Persi is a star and a variable star at 17 degrees. Let's go there next. That'll be a good interim spot to go. Wonder why we're not getting much audio from Astroplanner tonight. It's kind of sad, isn't it? It's not telling us things. Okay, so this part of the sky does look less maybe it's just a darker part of the sky. Well, there's that star we're trying to find. It's Beta Persi. And this is a star plus a variable star. It's object number 848. 848 of the 1001 celestial wonders to see before we die. So dramatic. Oh, is this Algol? It is. This is Algol. How about that? Let's see where we're looking. I'm going to have to put a paper clip on this because my book is wanting to open up. So let's sync with Stellarium. There's our voice. And where is Stellarium? Right there. Algol. So it looks like this is east-northeast. So just above our tree horizon. And this is one of the objects that makes up the constellation Perseus. You can think of Perseus as a kind of tuning fork, can't you? And in one of the arms, the one that rises first, here's Algol. Okay, back to our live view now. There's Algol. And it says it normally shines at a bright magnitude 2.1. But every 2 days, 20 hours, and 49 minutes, it dims to 3.4. So, at maximum, Algol is 3.3 as bright as when it's at its minimum. This dip in brightness occurs when a faint, unseen orbiting star orbiting Algol passes in front of it and blocks some of its light. Each eclipse lasts approximately 10 hours. Let's go to Stellarium and see what the magnitude is right now. If Stellarium will let us know that. Why is the magnitude not here? It's odd, isn't it? Looks like that's a custom marker. There we go. Algol. Magnitude is 2.05 right now. Oh, how about that? Oh no, that's correct. Shines at a brightness magnitude of 2.1. So probably just rounded up. 2.05, unless it is dimming. The first eclipsing binary star to be discovered by Italian astronomer Gimignano Montanari in 1667. Oh, it's the first eclipsing binary ever discovered. Algol remains the easiest to observe. Most of the time it appears nearly as bright as magnitude 1.8 Mir-Fak Alpha Persi, but keep an eye on it and you may catch it when it's fainter than magnitude 3.0 Delta Persi. So this star, Mir-Fak, is magnitude 1.75. So it's most of the time it's nearly as bright as Mir-Fak. The name Algol comes from Arabic Ras al-Ghul, the demon's head. Although some historians have tried to link this name with Algol's changeable brightness, that is incorrect. The name dates from the time of Ptolemy, many centuries before anyone discovered the variability of any star. Okay, so let's go back to our sky view. Boy, look at this. Look at this. Just haze. It's just kind of a haze, isn't it? Right here is where we're observing, I believe, Algol. Okay, back to the live view of Algol in our RASA. So how about that? Now, if you had never seen the star Algol, now you can say you saw it. How about that? I bet your life is pretty much complete now, right? can't say that we had ever before observed Algol, the first ever discovered variable star. Eclipsing binary. Eclipsing binary. So keep in mind, we've just seen two different kinds of variable stars. The first variable star varies in brightness because of the nature of the star itself, kind of pulsing on its own. The second star dims because an unseen secondary star eclipses it. It just happens to be, from our vantage point, as we look at Algol, this eclipsing orbit is in our way, and it happens on a exact 2-day, 20-hour, 49-minute time window. So I've heard of Algol all my life, but I've just never taken time to observe it. That's kind of fun. All right, we've got, Mike says, well done splitting the star in spite of the focal length we have. Imad Ibn Hatin says, planets are very small, a lot of them in the sun's view and too far to see. You want less mass nearby compared to our solar system formation. If it's too busy, most likely to large masses of sun and planets go for less mass, less busy. Solar systems don't need to have large planets, either small ones are more likely. Okay. All right. The next object we're scheduled to look at is the Helix Galaxy. Now, this is going to be a test of how, no, that's 7 degrees. I'm sure we won't be able to see that. It's just too hazy. So why don't we try this one at the Dusty Hand Galaxy, of all things, which is at 28 degrees. It has a magnitude of 10. So let's try that. The Dusty Hand Galaxy. By the way, we were trying a new scope cam tonight. It's a, yeah, Tiffany says, yep, life is now complete. The new scope cam we were trying is an MX Brio. It's supposed to have great like almost night scope view ability, but it did not. We could not get it to work. Stellarium sync. Okay, so that is the Dusty Hand Galaxy. And for context, this is east-northeast at about 28 degrees. So just down to the right of Polaris. It's NGC 2146. So now let's go over to our live view through our ZWO ASI2600MC Pro. See, now it looks like still we're seeing some haze there, doesn't it? But let's give this a try. We're going to say NGC 2146. And we'll let it plate solve and it did find enough stars to plate solve. Anyway, this MX Brio, I guess I'm going to have to send it back. I'm trying to find a webcam with almost a night vision capability, and so far I've not been able to. Okay, so let's just do quick auto stretch and a quick color balance. Somewhere in the middle of this frame is supposed to be our galaxy. So we'll try plate solve, solve only, and then deep sky image annotation, which is Alt-D. So there is NGC 2146. It's supposed to be right here. So I'm going to click on the screen and go Alt-D to remove that. So it's supposed to be right here. I wonder if maybe with that haze, if maybe we're not going to be able to see that galaxy. In the meantime, we'll read about it. 978 is the object number. $978. Yeah, Mike, I generally wait till after the plate solving and after the first exposure to grab it, to change the ZWO ASI2600 view, because it's pretty boring until that happens. 978. The Dusty Hand Galaxy, magnitude 10.6, 5 arc minutes wide. What an interesting looking galaxy. It's too bad. I think it's going to be a little too much haze. It says it's undergoing major burst of star formation. There aren't many bright stars in the area. Got its common name from images that showed a system of 3 dust lanes, which may be spiral arms. Astronomers have found clear indications of starburst activity, such as a strong galactic wind. In most cases where other galaxies have displayed strong star-forming activity, a companion is responsible, usually seen merging with the main galaxy. Although NGC 2146 shows no obvious sign of a merger, that scenario seems to be the most plausible explanation. Probably the encounter happened long ago, and it happened so long ago there are no traces left. So once again, I'm going to tap on the screen and say Alt-D. That's supposed to be where the galaxy is. But I fear that with our general haze tonight, okay, we're gonna dial up our mids a little bit. Okay, we are seeing a splotch. We're at 243%, so well above our optic. We are seeing a splotch in the middle of all that grain. We're at 4 minutes integration. Right here we're seeing a splotch. But there's so much haze, I think what we'll do is we'll say we could see the presence of a splotch, but there's a fine haze all through the sky tonight, and it seemed to be hiding the beauty of this galaxy. So let's come back to it later and see it again when things clear.
Observation log.
Because it's just not. You can see a patch there, can't you? At 5 minutes and 40 seconds, you can see a patch. But for a magnitude 10 object, it should already go back to Stellarium. Let's make sure our Stellarium field of view is, there's our Stellarium field of view. So now with the help of, as Pete calls it, human plate solving, okay, so see these three stars. I wonder if it's that row there. And then this is this wishbone pattern right here. See that wishbone pattern? So there's the wishbone. The wishbone points at these three stars. Here's the wishbone, points at these three stars. And then the Dusty Ant Galaxy is kind of in a curve off to the left of those three stars. Yep, right there it is. But it's so mixed in with the haze tonight. So tonight might be a good night to stick to more of those star patterns that are in the 1001 objects, because we're not going to see much of the beauty of these faint galaxies, are we, with that haze going on? But you've at least seen where the galaxy is, although you've not seen it in all of its beauty. Okay, so let's go to our next object. And so what we'll do is we'll scan down through and look for here's one Camelopardalis. Let's go there. That's one, let's call it HD 28446 in our one Camelopardalis. It's at 17 degrees altitude. I hope that's high enough. lots of haze. That is not going to be. Looks like we're into a tree there, so I'm going to change our Emerald Hills Low Horizon. See here up at the top, I got this set on Emerald Hills Low Horizon. Now I'm going to set it on Emerald Hills, and that'll keep us up higher. It won't even show the objects as visible if they're below the tree horizon. So let's try the that's magnitude 5.3. Let's go to Struve 331. Who's ever been to Struve 331 among us? Well, now look, now that I've turned off the plate solving, I wonder if that was one Camelopardalis. It just came out from behind that tree. It is. It just came out from behind that tree. This is one Camelopardalis. And let's sync with Stellarium.
Selected.
Whoop, I do that sometimes. So we're looking east, northeast, or north, northeast, I guess. See, this is the tree line, and it's just come out of that tree line. This red line in our planetarium software represents the tree line. So look, there's the double star, one Camelopardalis. And there you're looking at it. Just fresh from the tree limbs. Object number 909. 909. This pretty binary makes a nice target for northern observers. The primary is sky blue and the secondary is white. Because Camelopardalis is such a faint constellation, find one Camelopardalis by using it tells you how to find it. The separation is 10 arc seconds. And it should be blue and white. I don't know if we're seeing that color very well tonight. That's at 200%. Because of the haze and perhaps, no, I think we're out from the tree limb now. It's just the haze. We're not seeing very much of that color, are we? We saw this double the moment it emerged from behind our tree line, but because of the haze, we couldn't detect much of a color difference. I should ask if you guys are seeing it. JM, looks like you've got your telescope there. We've got 19 folks on. If you haven't told us yet where you're observing from, please let us know what city you're observing from. Can anybody see color in these two? Any color difference? Because I sure can't. I think the haze is robbing the color from us.
Observation log.
Let's go to this Struve 331. Now you notice we're not live stacking these. That's because most of these double stars and such, you really don't need to live stack it much. There, I bet that's our star, Struve 331. Sure enough.
Selected.
So we'll look at this for a moment at Stellarium, which is our planetarium software. Now notice, remember a while ago we were down here looking at Algol? Now we're up here to the right of this wishbone, or whatever you want to call it, that is Perseus. So we're north-northeast. Struve 331. It's another double. And that's 100%. You can already see it's a double there. And it's object number 847. You know, a lot of people get into double stars. I've never been a big double star guy for some reason. This nice pair lies near the Pleiades, but the easiest way to find it is to start at magnitude, and then he tells you the stars. The separation allows splits, though through even small telescopes. The primary shines lemon yellow, and the secondary is pale blue. Boy, I just don't see the colors. Tiffany is viewing from smoky Northern California. Tiffany, I think we have some of your smoke here in Louisville, Kentucky tonight. Can you see any color difference between those? Why don't we drop this down to 2 seconds? Maybe 1.5 seconds. And let you look again. Maybe 1 second. Okay, so maybe this one is the pale blue, and that one is the lemon yellow, you think? This is Struve 331. Anybody see a color difference between those two? I certainly don't. We could split these, but under tonight's haze, we couldn't make out any color difference. Wonder why it's only, wonder who Struve was. Anybody know who Struve was? JM. You're from the Ozarks, and you're very kind to say thanks for your continuing dedication to putting these community viewing sessions on. So JM does see greenish and whitish. Tiffany can't make out the color. Maybe it's just because I'm colorblind. Okay. Well, that's Struve 331. I'm just going to go real quick out to here and say, who was Struve double stars? Friedrich Georg Wilhelm von Struve, 1793 to 1864, and Otto Wilhelm Struve, who was the son of Friedrich G. Lived in Europe his entire life, became a professor of astronomy, what was then known as Dorpat University in Estonia. These two members, these two guys, are the ones we typically associate with double stars, of all things. Father and son. Well, it's nice. They did a catalog together. Oh, top one yellow, bottom blue, Tiffany says. Very slight difference. All right, now let's see what else we can find that'll work on a slightly hazy night. Wonder if we could see an open cluster at magnitude 7. Let's try that. We're not live stacking anymore. Tiffany and JM were in a bit of disagreement over which one was which. This is NGC 957.
Selected.
So now we're looking north-northeast still. Look at the double cluster. Oops, sorry. Look at the double cluster up here. Now, this is not a very thick cluster. I'm not even sure that we would have been able to tell that it was a cluster. It's a pattern of a little bit like, what does that look like to you? A snake slithering along the earth. A python, you know? No. A diamond pattern? No. What are you guys seeing here? Anyway, let's see if we can find it for real. Wow. Not seeing it at all. Oh, I wonder if we need to open up our aperture a little more. Go 3 seconds. I'm looking for our snake. Is that our snake? Right there it is in the middle. I would have never seen that as a cluster. How about you? NGC 957. It's object number 830. Eli, good to have you aboard. JM is just good at emojis. Object 830. I'll tell you what, why don't we this is NGC 957. Let's just stack this just for a second. This is object number 830. Hi.
It's Tim.
Hey, Tim, how are you?
All right, I sent you a text so I wouldn't scare you.
Okay, thanks. Sorry, I've been on the live stream. I wasn't looking at my text. Sorry.
Okay.
Good to see you, brother. Tim's just checking in on me there. 830. He says, yeah, he says you can't find very many stars at first. Some nebulae glow because a hot star within them emits enough. Oh no, this cluster star, there's 24 stars. So he says we should be able to see 24 stars. Let's tune this up a little. Oh yeah. That helped to stack it, didn't it? So a longer exposure, and now we've got 80 seconds of stacked frames, 20 seconds each. Now it looks like a cluster, doesn't it? Yeah. Okay, so at 3 seconds, this barely qualified as a cluster, but at 40 seconds of integration, we could see a couple of dozen stars. So here's my question. How did Herschel find all these with an 18-inch scope? Tiffany says, good man, Tim, checking on me. You're nice, Tiffany. How did Herschel find all these? It's just amazing, isn't it? He was using an 18-inch scope on the edge of what town in England? I forget. And how did he find these? Bath, I think. NGC. The next one is 956. So in this particular collection of objects, you get a lot more variety of. Herschel had dark skies and no internet. So he had, JM is saying he had the time to look. You get a bigger variety of objects than what we've been seeing. So, I mean, you know, it's good because it makes us go to things we wouldn't normally look at, I think. I've never done much binary star work, and I think a list like this is good for us because it makes us, you know, kind of like broaden our horizons some. Is this the heart cluster? Because right away, look, see the heart shape? Now we've imaged or looked at the heart cluster before, but maybe it wasn't under this, maybe it's NGC number, and so we didn't have it recorded as having been observed. It looked like we had never observed it before, but I know in a Valentine's Day observing session, we did the heart cluster. We observed it. Oh, I think that's a mistake. I think in order for this to work, we would have to go plate solve only. Now, yeah, that's what I thought. You know, after SharpCap plate solves and then moves the field of view so you can see the target right in the center, now deep sky image annotation is off equal to the amount that it moved after the plate solve. Anyway, let's read about this. I'm sure that's the heart cluster though, 956. Could that be right? Oh no, I'm sorry. 829. I was looking at the wrong number. 829. Object 829. You'll find our next treat, and it tells you where to find it. This odd cluster has two 9th magnitude stars at its north and south end, a couple more 10th magnitude stars, and a dozen magnitude 12 and fainter stars. Well, maybe this is not the heart cluster. NGC 956. Tell you what, let's go out here and say the heart cluster, NGC 2323. So it is not the heart cluster, but look, it could have been. Does anybody else see that heart shape? Tiffany, are you seeing that? Pretty cool cluster, Tiffany says. JM says, my eyes are drawn to the numerous string of 3 star chains. Here's a string of 3. 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 It's the string of 3 cluster. I like it. All right, so let's say at first glance, NGC 956, we thought NGC 956 might have been the heart cluster. But it turns out that the heart cluster is NGC 2323. After looking more intently, JM christened this the string of 3 cluster. Ah, JM did see the heart. Lots of strings of 3 stars. Yeah, I think this one would come in as a close second. Pretty cool. All right. Now we could go to the alpha star of Ursa Minor. This is called HD 8890. So this is the brightest star of the Little Dipper. Yes, it was a heart shape, Tiffany admits, tilted to the side. Lots of haze still. But, you know, we have to cover these objects sometime, right? Now, it's supposed to be clear again tomorrow night. But then again, it was supposed to be clear tonight. JM says, yes, an emoji heart. Object 828. William Herschel discovered that Polaris was a binary star in 1780. Although the yellow primary outshines the blue secondary by more than 650 times, a 3-inch telescope will easily show you Polaris B. Okay, let's get our histogram lined up here. Okay, so we can see this little add-on thing here. Let's stop live stacking, and I think we'll see it better. See that? So good for Herschel that he discovered that. Man, he was a sharp-eyed guy, wasn't he? 1780. How did Herschel ever split these in 1780? So what you're looking at there is Polaris. So the North Star is a double star. Tiffany says, I'm outside looking up at it now. Ursa Minor. Yeah, if you can find the North Star, then you're seeing it real time, and it's a double star. Pretty fun. Let's go to Iota Trianguli. Iota Trianguli tonight is about 30 degrees up.
Selected.
And you can see it's east-northeast. So it's right below the constellation Triangulum. Boy, do we have that lost in trees? Shouldn't be, should it? Why are we not seeing any of this? At 30 degrees, that should be above our trees. I wonder if that's just solid haze now. Yeah, plate solving won't work because there are no stars there. Let's go back to SkyCam. Oh yeah, look at that. It's just solid cloud bank. Take a look. Just nothing there at 30 degrees. Bummer. Let's try Sigma Cassiopeiae. Slew, baby, slew. JM, we missed you saying that. Glad you're back. Well, I'm sad that our MX Brio webcam wasn't able to see. Tell you what, let's try it again. I'm going to go to the scope cam screen and I'm going to remove the Brio and then re-add it. Video capture device, MX Brio. Just doesn't even seem to be functioning, does it? It's like it's not working correctly. Surely it's brighter than that. But sadly, it's not working. We could open up this screen reflector deal and then slow. Just to see the telescope. Boy, it doesn't want to find it tonight. See, that's why I'd like to find a simple webcam. Because, let me go to this reflector deal now and close that again. I think it's just not a very good system. This is the way the telescope looks tonight. That's through the security camera that we've been using. There we go. But I can't get it to mirror correctly, sadly. All right, so look right there in the middle. That must be Sigma Cassiopeiae. It's surrounded in haze as well.
Selected.
Oh my goodness, JM, thank you so much for pitching in $1.99. Larry says, pretty good skies if you can see all of the little bear. Yeah, we can just see the brighter stars, the constellation. JM, thank you so much for pitching this in. You're very kind. Really means a lot. Now, which... That's at 100%. Let's go over to Stellarium. Do you think, this is object number 745. Look for sigma Cass. The two components lie fairly close together, so use a magnification of near 150 to get a nice split. Many observers describe both stars as white, but bluish white seem to be the next most chosen colors. 3 arc seconds apart. Oh, look, very close. Okay, so right there, in the middle of all that pixelation, you can see that it's just starting to become, you know, our focus. We could tune up our focus and do a little better, but it's just starting to become two bodies. There you go. Whoops, you can't see that. It's just starting to become two bodies. See how it's split up? You kind of have to pretend through the pixelation. Tell you what else we can do. Boy, that focus is not terrible. It's just that we're having to blow these up so much bigger than there. See how they're two different objects there. And I would say that it's right one of them seems to be white, and the other one has a different tinge, doesn't it? Wow, so Larry bought a zip-up hoodie with the Emerald Hill Skies logo. Wear it all the time while you're observing. Bless you, Larry. JM is telling others to check out the store too. Greenish hue to these objects. Yep. Okay, so we're going to at 450% of our optical zoom, that is severe digital zoom, pixelated, we could split this double and detect some color variation between the alpha and the binary. Sigma Cass. First time in my life I've ever observed Sigma Cass. Oh wow, Bruce pitched in $4.99. I'm glad to catch another live stream. Thanks for all that you do in the channel. Very helpful and informative. He gave a fist pound and a cool Joe emoji with nice shades on. Bruce, that's so nice of you to pitch in again. $4.99. You guys are too amazingly kind. Thanks. Tiffany says, Bruce, you rock. Let's go over to our Aquarii. Our Aquarii. So let's drop this back to the default, 100%. Aquarius, Aquarius. You know, I wonder if we should focus again. Boy, look at all those clouds. You know, in that view, you can see my window. I'm going to walk over to the window and say hi. I'm going to take a flashlight. I'm going to put it on red. And say hi. Could you see it? There it is. Now you notice I've got the red lights on in the observatory tonight, and boy, they just really are dominant in that view, aren't they? The Skycam view. But in the, oh, look at that. No stars visible. Let's go back to Skycam for a minute and check out why. Well, that's why, because all of that, and this is at 28 degrees, all of the lower third of the sky is just one big cloud bank now. So we're gonna have to get up into like $70 degrees above the horizon. Let's try going to Lacerta for whatever reason. Lacerta. This is object 694. One object I propose you seek out is the small, faint constellation Lacerta, the Lizard. Talk about a loser. Lacerta contains none of the 200 brightest stars, no named star, no meteor shower, and no Messier object. What's worse, no celestial map pictured Lacerta prior to 1690. In that year, Johannes Helvelius included it, and 6 other new constellations in his star atlas, which nobody can pronounce. Now that's a mouthful. Sobiesianum sive uranographia totum socolium stellatum. Look for Lacerta directly south of Cepheus and roughly 20 degrees east of Deneb, Cygnus the Swan's brightest star. Don't get your hopes up. Lacerta's alpha star glows only at 3.8. Okay, so let's go over to Stellarium. And there is Lacerta the Lizard. So we're looking at east-northeast. And look at the inverted house. And look how if you take a diagonal across the house, it should point at the lizard. There's the lizard's head. 1, 2, 3, 4, 5 stars, and this one's a diamond. Let's see if we can find it in the sky cam. Okay, so anybody see Cepheus? There's Cassiopeiae. If the Big Dipper is down here, Cassiopeiae should be up here. Why am I not seeing Cassiopeiae? The Big Dipper's here. So Cassiopeiae. Anybody see Cassiopeiae? There's Hercules. If the Big Dipper is here, Cassiopeiae should be here. Why are we not seeing Cassiopeiae? Too much interference, I guess. Well, then maybe this is not Cassiopeiae. Boy, there's so much sky glow from the clouds, huh? This must not be Cassiopeiae. Anybody make anything out? Tiffany saw the hello flashlight. Part of it might be because we're laying on our side. Maybe that's one of the dipper handles, maybe. This dipper handle here. So maybe that's... Oh, look, there's Cassiopeiae. So is this Cassiopeiae? Yes. So this is Cassiopeiae. Cepheus is here. So this is the diagonal we go through, and here's Lepus. So this is the diagonal of his head, and then curves around there. So see the diagonal? No, it curves up like this. The diagonal of his head, and then curves up like that. Boy, he's not very... Bam, bam, bam. 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 So bam, 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 bam. Lacerta. Everybody caught him? Caught the lizard? Boy, with all the haze, and the distortion of the telescope on its side. It took a while to get our bearings, but we finally captured the lizard.
Observation log.
JM says, great eye, Doug. Dave, good to have you aboard. You pictured Cassiopeiae right away. Down here. Good. All right, let's bring this back out to auto. And let's see if we can find, oh, that's too low. Here we go. Chi, is that what that is? Xi Cephei? Cephei? So there's Cassiopeiae, and then here's Cepheus. Look how the house has a rounded bottom to it.
Selected.
Those, whoops, I did it again. Anyway, right in the middle of the house is this middle star. (21°). What? How could that be 21 degrees off? I guess this is a byproduct of all the haze. Okay, there's our star, Xi Cephei or whatever. Does look like it's more than one star, doesn't it? See how it breaks apart into two stars when we very pixelated. We're at 467% of our optical zoom. There. You can tell it's two stars there, huh?
Selected.
This is in the constellation Cepheus. It's right there in the middle, right? Yeah. Could see this double right away. It's object number 696. To find Xi Cephei, look for a star at the midway point between Alderamin and Iota Cephei. Although many observers see both components as white, some describe the secondary as a dull yellow. Okay, maybe right, maybe. This may be due to the magnitude difference between the two stars. Xi Cephei b shines only 1/7 as bright as the primary. According to Richard Hinckley Allen, Persian astronomer and philosopher Al-Qaswani called this star Al-Qurba, an Arabic word that German astronomer Christian Ludwig Edler translated as a white spot or blaze in the face of a horse. Huh. The binary, the lesser of the two stars, shines only 1/7 as bright as the primary.
Observation log.
You're kind to encourage, Tiffany. Snowman. All these different emojis, JM. Where do you get all these? All right, now let's go over to Mu Cephei. Yeah, I'm going to have to send that webcam back, sadly. I guess if you guys find a webcam that's basically got night vision is what we're looking for. Boy, it just seems like this one should be working. Maybe it's got something to do with the fact that it's an 8K, I mean, in other words, not just 4K, it's 8K. Maybe the data cable is not functioning correctly because it terminates in a USB-C and I'm having to adapt it to USB-A. So maybe it isn't functioning correctly. I'll have to check that out somehow. Okay, here we go. This is Mu Cephei. Definite orange tint, right? Boy, are we supposed to be able to split that? Mu Cephei. Object 683. Look for Herschel's Garnet star, almost 5% mu color. Won't be immediately apparent to your unaided eye because it isn't bright enough to trigger your color receptors. The best approach to seeing the garnet color is to ever so slightly defocus telescope. The tiny disk you'll create will then display its copper, ruby, rose, or garnet color. Which is it? That depends on your eye's color receptors. JM says, Doug, via the Google keyboard on my Pixel 8, I'm watching on both Android phone and color TV. That's where you're getting all these emojis. Chatting from the phone provided access to all the typical texting emojis. So, I guess we're not supposed to be able to split it. It's just supposed to be garnet to us. And it is, isn't it? This is Herschel's Garnet star. Let me write that down here. I'm going to add that to the description. Herschel's, only one L in Herschel. Garnet star. This is one of the most orangey stars we've ever observed.
Observation log.
Pretty much a garnet, right? All right, we're in our last 12 minutes. What else can we pick up that's high and not a galaxy? Because things are still very thin haze up there. What about a here's another Struve. Are you guys liking these double stars? What do you think? Do you think you might become fans of double stars? Oh wow, is this a triple? Look at that. Struve 2816, it's object 676. Our next target gives you 2 treats for the price of 1. Although you'll observe the triple star system, Struve 2816, you won't be able to miss open cluster Trumpler 37, sometimes called the Misty Clover Nebula. That's because the star lies pretty much dead center within the cluster. Okay, let's stack. So first, let's take a quick picture of this because that's pretty cool, isn't it? This is Struve. Struve 2816. Now, let's Struve 2816. Tiffany loves the double stars. JM says, reminds me of Orion's belt. Well, that's pretty cool. So this is a part of the hobby I've never done before. Splitting double stars. Wow, so that is the cluster there in the middle. And what is the name of the cluster? We saw the triple star system instantly at just 2 seconds exposure and saw the cluster Trumpler 37. At 20 seconds.
Observation log.
Trumpler 37. Just seems like that we ought to say add Trumpler 37. No result. That's really quite a cluster, isn't it? Struve 2816. Pretty impressive triple star system, right? Yeah, Tiffany says nice triple target. It's pretty nice. All right, we just got 5 minutes left. Let's go to this one should work. It's an open cluster. Look at all that haze. Oh, JM just gave $5 more. Thank you so much. You guys are too kind. Bless you. Who does that? All right, so this cluster is supposed to be NGC 7082. Yep, right there in the middle. right there. It's object number 670. When you first look at NGC 7082, you might think, oh, what a rich cluster. Not really. Here's a good example of a poor star cluster superimposed on a rich Milky Way background star field. Basically, there are just 20 or so stars in this cluster. We're just looking at these as 3-second frames without stacking. And you can already see the cluster here. You could see this cluster, 20 stars in just 3-second live, let's see, 3-second single frames.
Observation log.
All right, well, I want to apologize that we've had this thin haze all night. It's probably Tiffany's fire smoke that's come out our way. No, just kidding, Tiffany. But it really has been a limiting factor for us, especially at the lower altitudes closer to the horizon. We weren't able to see anything faint down there. So we'll scout out another clear night and come back. But even as it was, we managed to observe, well, let's see. I guess what we can do is look at tonight's 14 observations. We were able to pick off 14 of these 1001 objects. As it stands, you'll see that at the end of the yellow section, once it turns white, we've already got observations of all these because of the fact that they're on other lists that we've already observed. So we started from scratch tonight, but we really didn't. Since these objects in white, we've seen some of them, I see a few numbers there that are like 15 or more times. Once you get up into the yellow, these are objects we've not looked at, in spite of the fact that we've finished the Messier list, the Secret Deep, most of the Hidden Treasures, all of the Herschel 400, and what am I missing? Oh, the Caldwell list as well. So in spite of having finished all those other lists, these represent new frontiers for all of us, I think, that are on the channel. We haven't observed them ever on this channel. So it is going to be a fun list. It looks like we have 499 left. So we got it down just below 500 tonight. And we'll try to find another clearer night, so we can pick up some of these more faint galaxies and all. If you enjoy content like this, make sure you click a thumbs up. Subscribe if you like, and that way you'll be notified through your YouTube credential if you have one. Maybe click the bell so that you'll be given a heads up. But you can also go to emeraldhillskies.com and sign up there on the very brief form so you'll be notified by email as well. We're sorry about the haze tonight. JM, did you give another $5? I can't keep track. Tiffany, thank you for being here. JM, you're very kind. Tiffany says, best regards to all in the chat. JM says, I enjoy these online viewing parties. Larry says, thanks for the show. Good night, all. Bruce, if you're still there, thanks for being here. All the others of the 15 that are with us, thanks for being here. God bless you guys, and thanks mostly to God, who He makes all these objects so that we can see them all, and we'll look forward to catching more of them next time. I hope you'll be back. If you're watching this channel recorded, if you're watching this broadcast recorded, thanks for being a part of that. Corin, thanks for being here, saying good morning. JM just gave another $3. My goodness. You know, we'll take all of the gifts that were done tonight and we'll lash them all up together and send them to a needy family as a gift from Emerald Hill Skies community. And I'm not sure which family that should be. Maybe tonight we'll do that as a needy local family. Tiffany says, hoping for clear skies. We look forward to seeing you again. Again, thanks to God for making all these objects. Good night, and